Hey you guys, it's Miss Latham. I want to go over some trig identity stuff with you, some examples. First, I want to talk about some of the formulas that are very important for this process. I sent you a PDF, and this is the PDF that I sent you. It's called the Trig Cheat Sheet. We'll be focusing on the formulas on page 2. You have the quotients here, tangent of theta is sine over cosine, cotangent of theta is cosine over sine, and then of course the Pythagorean identities, especially sine squared plus cosine squared equals 1. The even and odd trig functions, and you can see here that cosine and secant are the only ones that are going to be even. The rest of those bad mama jammas are odd. The sum and difference formulas is very much throughout the lesson. It has both signs for the two formulas put together. So if I wanted to do the sine of alpha plus beta, I would look at the top sign over here. And if I wanted to subtract, I would look at the bottom sign over here. All right, and then the last ones on page 2 of the PDF I sent you are the cofunction formulas. And that's just where the sine of pi over 2 minus theta is equal to the cosine of theta. And you guys remember that pi over 2 radians is the same thing as 90 degrees. Just in case the problem's in degrees instead of radians. And I believe that's all we're going to need for this lesson. But I would definitely print out this PDF. If nothing else, page 2, and it'll help while you complete your problems. So I'm going to do some examples with you now. So here we go. The first one, they want us to rewrite the expression. So this is kind of like one of those problems where we would verify, but we've only got one side of it. So remember, one of the popular strategies is to turn everything into sine and cosine. First thing I notice is I have the tangent of negative x, and we got to ask ourselves, is tangent an even or an odd function? And tangent is an odd function. So what we can do is rewrite that as the negative tangent of x times the cosine of x. All right, and then what else do we know about tangent? Well, we know that tangent is the same thing as the sine of x over the cosine of x. Do not forget that negative out front. And I'm going to multiply that by the cosine of x. And now, we have this cosine in the denominator and that cosine, and we can just cancel those bad babies out. And we are left with the negative sine of x. And that's it for that one. All right, let's look at the next one. They want us to find the sine of 75 degrees. Well, on our unit circle, we don't have the 75 degrees, so we're going to have to use a sum or difference formula. So we want to think about two values that are on the unit circle that we can add or subtract and get 75 degrees. What I decided to use was the sine of 45 degrees plus 30 degrees. Okay? And then I'm just going to plug those into the formula for the sine of alpha plus beta. So that would be the sine of 45 degrees times the cosine of 30 degrees plus the cosine of 45 degrees times the sine of 30 degrees. And these values will come right off the unit circle. The sine of 45 degrees is the square root of 2 over 2. The cosine of 30 degrees is the square root of 3 over 2 plus the cosine of 45 degrees is the square root of 2 over 2, and the sine of 30 degrees is a half. And we're going to make that look prettier. The square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is 4. The square root of 2 times 1 is the square root of 2, and 2 times 2 is 4. And since they have a common denominator, I'm going to write that numerator is one expression, so the square root of 6 plus the square root of 2 over 4. Now I noticed that it suggested checking your answer by putting it in the calculator. So what I'm going to do is get this calculator and just show you. And I know you don't have these at your house. Some of you have some of you don't. You can always use Desmos or the Wabbit. So I'm going to do, make sure your mode is in degrees, and it is. All right, the sine of 75 degrees, and I get, let me see if I write this down. So the sine of 75 degrees is approximately 0.9659. And now I'm going to plug this into my calculator and see what that is. So I'm going to put the numerator in parentheses. So the square root of 6 plus the square root of 2 divided by 4. And look, oops, approximately 0.9659. Same. So we know that our answer is correct. Be sure when you're using Pearson that you pay very good attention to how they want you to round. It's important. All right, let's do another problem. Okay, next they want me to do the cosine of negative 15 degrees. I don't know the cosine of negative 15 degrees, but I do know the cosine of 30 degrees and 45 degrees. So I'm going to use my formula for the cosine of a difference. So that'll be the cosine of 30 degrees, cosine of 45 degrees, plus the sine of 30 degrees, the sine of 45 degrees. And then we just take the values off the unit circle. The cosine of 30 degrees is the square root of 3 over 2. The cosine of 45 degrees is the square root of 2 over 2. The sine of 30 degrees is a half. And the sine of 45 degrees is the square root of 2 over 2. I'm going to simplify, so this will be the square root of 6 over 2 times 2 is 4. And then 1 times the square root of 2 is the square root of 2 over 2 times 2 is 4. We just go straight across when we multiply fractions. And again, I'm going to write the numerator as one expression, so the square root of 6 plus the square root of 2 over 4. And that's it. Now, this next one is pretty interesting. It says, and I may have to scoot over so you can see all the question. It says, does a noise with a sound wave y equals the sine of 1100 pi x cancel out a noise with a sound wave y equals the sine of 1100 pi times x minus 1 over 220. Okay, so to see if these two things cancel each other out, I would need to add them together and they should equal 0. So that's what I'm going to do. So I have the sine of 1100 pi x, plus the sine of 1100 pi times x minus 1 over 220. All right, and what I'm going to do is distribute this, and that'll give me all right, so 1100 pi times x would be 1100 pi x, and then 1100 pi divided by 220. So how many times does 220 go into 1100? And that would be 5. Don't forget your pi. All right, so we have the sine of a difference. So I'm going to use that formula. And I need to scoot over, make sure it's showing up. So we have the sine of 1100 pi x plus, and I'm going to write this in great big parentheses. So this right here will be our, if you want to think of that as our alpha, and that is your beta. So I'll have the sine of 1100 pi x times the cosine of 5 pi minus the cosine of 1100 pi x times the sine of 5 pi. Okay, well, we can plug in values for some of this. So the cosine of 5 pi. Now, you can either use the periods of cosine, or if you want to, you can go around 5 pi around the circle. And the cosine of 5 pi would be -1. And this would stay the same. I can do the sine of 5 pi. So if I go over to the sine of 5 pi, that would be 0. It's the same thing as the sine of pi and the cosine of pi. Because I can take 4 pi away from both of those. All right, so I'm going to write this simplified a little bit. Okay, let me scoot over a little bit. So now we have the sine of 1100 pi x minus, because this negative is going to make that negative, the sine of 1100 pi x. And then if this is 0, 0 times this stuff is just going to go away, right? Because 0 times anything is 0. So, I mean, I can write the minus 0 for right now if it makes it feel better. And what about this? I can combine these, or like terms, they're exactly the same thing. I have a sine of 1100 pi x minus the sine of 1100 pi x. Those are going to go away, and I am left with a great big fat 0. So, do they cancel each other out? Yes, they do. Okay, let's move on to the next example. It says, given this point on a circle with a radius of 10, express the x-coordinate in terms of sine of theta or cosine of theta after 2 rotations. Well, if you're at some point on a circle and you rotate all the way around one time, you're exactly where you started from, and I can go around another time and I'm going to be where I started from. So basically, we're just going to look at this x-coordinate and see how we can rewrite it. So the x-coordinate is... Let's scoot up a little bit. The x-coordinate is 10 cosine of theta plus 45 degrees. All right, so this is the cosine of a sum, so I'm just going to use my formula for that. So that'll be 10 times, then we'll have the cosine of theta, cosine of 45 degrees, minus sine of theta, sine of 45 degrees. All right, and we can plug in values for those 45 degrees. The cosine of 45 degrees is the square root of 2 over 2. And the sine of 45 degrees is the square root of 2 over 2. So I'm going to factor out that square root of 2 over 2. So we have 10 times the square root of 2 over 2 times the cosine of theta minus the sine of theta. And you just need to simplify this and we'll be done. 2 will go into 10 a whopping 5 times, and I'm left with 5 times the cosine of theta minus the sine of theta. And we are done with that one. All right, the next one is some of the stuff you guys really like. Verifying. It's my favorite. All right, so we got sine times secant times cotangent, and we want to show that that equals 1. So what I'm going to do is change everything to sine and cosine. So sine is good. I know that secant is the same thing as 1 over cosine. Don't forget your theta. And I know that cotangent is the same thing as the cosine over sine. All right, well, we got a sine in the numerator, a sine in the denominator. We have a cosine in the denominator and a cosine in the numerator. So cancel, 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 cancel. I'm left with a 1 and done. All right, let's do another problem. So for this one, they want me to evaluate the sine of alpha minus pi over 2. I'm just going to use my formula, except we just so happen to have alpha instead of a number. So this is the sine of a difference. So I'll say the sine of alpha cosine of pi over 2 minus the cosine of alpha sine of pi over 2. We know a couple of these things. The cosine of pi over 2 is 0. And the sine of pi over 2 is 1. As we mentioned earlier, 0 times anything, ka-chow. And we are left with the negative cosine of alpha. And we're done with that one. All right, let's do another verifying. I'm going to do these two and then we'll stop. All right, for number 8, it wants us to verify that the sine of 3 pi over 2 plus theta is the same thing as the negative cosine of theta. So I'm going to use the sum of sine formula. So that will be the sine of 3 pi over 2 times the cosine of theta plus the cosine of 3 pi over 2 times the sine of theta. And we want to make this side look like this side so we can verify it. What is the sine of 3 pi over 2? Well, that would happen to be negative 1. Again, think about your unit circle, or if you got it printed out, look at your unit circle. The cosine of 3 pi over 2 is a big fat 0. This is going to go away. And then negative 1 times the cosine of theta is negative cosine of theta. We got where we wanted to go, so I'm finished. All right, let's do another verifying. We want to verify that the cotangent of negative x times the sine of x is the negative cosine of x. So I know that cotangent is odd, so that's the same thing as the negative cotangent of x times the sine of x. I also know that cotangent is the cosine of x over the sine of x. These two lovely signs will cancel out, and I've got the negative cosine of x. And we're finished. Alright, you guys, I hope those problems help, and I will post some more videos later. Good luck, and I miss you so much.